All right. So it is Monday. It is October 4th, first day back from a long break. We have a lot to talk about here. Are you ready?
Yeah.
Chromebooks are closed. You're ready to listen. This Cactus notebook today, we have a lot to remember. We have a lot of things we need to remember from our fractions lesson before the fair. So let's get right to it. The question is, the directions say, record the greater of the two fractions. And so you have two different fractions here that they want you to record the greater. So we have two different times to record the greater fraction. So I wanted you to label your Cactus notebook to look like this so that I saw an A and a B. That was what I wanted. So for A, we are going to be labeling the greater of the two fractions. Same for B. All right? So we're going to put something inside of each of these two circles. What do we call the thing that we put inside the two circles? What do we call that? What do we call it, Bradley?
Alligator.
We call it an alligator, right? That's what we always know it as. So if we have a 2 and a 3, we know the alligator wants to eat the bigger number. Am I right?
Mm-hmm.
That's what we call it. But you know how it is when you have little kids around and you say cutesy little things to little kids that you wouldn't say to your friends. You know what I'm saying? You know, you say 2 and 3, you're like, which one's bigger? Which one does it? Okay, so let's say I'm going to ask you to take a bite of your broccoli. When you're 9 or 10, I'm going to say to you, take a bite of your broccoli right now, right? But when you're 2, I'm going to say, ooh, the broccoli, it's on an airplane. Here we go. Right? That's like baby talk. You know how you have that with little kids? You know what I'm talking about? You know what I'm talking about? You got to teach them. You got to tell them the cutesy things at the beginning so that they do the stuff they don't want to do. You know what I'm talking about? Does anybody know what I'm talking about?
Yeah.
Yes, we know. Okay. The alligator, that's the cutesy way we teach it to you. Which one does the alligator want? The big number. You know what I'm saying? Does anybody know what this is called in over at the high school? Because I guarantee you, who has brothers and sisters over at the high school? Look at all these hands. Nobody at the high school is calling this an alligator. You know what I'm saying? Your brothers and sisters going to call that an alligator? No. So let's grow up a little bit, right? What are we going to call this thing? Does anybody know? Does anybody know? I hope that my alligator comment didn't hurt anybody's feelings. I wasn't trying to be rude. I was just trying to be a little bit funny. The baby comment. Was that rude? Was that unkind? I wasn't trying to be unkind. Do you know what it's called, Ella? Huh? Less than and greater than. So this one, if you make an L with your hand like this, and you can turn this up and turn it into the letter L, like, I love math with Mrs. McGinnis. Ain't that true?
Yes.
Yeah.
Huh? Ain't that true, everyone?
Yes.
Yes? No. You just say that, you don't mean it. So when you can turn that into an L, that is less than. The other way is greater than. These have a special name. These things here have a special name. They are called inequality signs. Because if we use our example here, are 2 and 3 equal? No, they're not equal. So we use these signs to compare them and tell us which one is larger. So for this one, am I going to use less than or greater than here? Raise your hand to speak. Go, Bentley.
Greater than.
Think about the alligator. Which one do you want to eat?
The bigger number.
The bigger number. And so am I going to use less than or greater than?
Greater than?
If I use greater than, I have to do that.
Oh.
Is that what you want?
No.
That's not true. Because, and the reason it's not true is because you read this like a sentence. You start here, you go left to right, just like when you're reading a book. 2 is blank than 3.
It's going to be less than.
It's going to be less than. Very good. 2 is less than 3. These are called inequality signs. Okay? So yes, when you're figuring these things up on your paper, do I want you to think of an alligator?
Mm-mm.
I do. I do. Because it's fun and I like it and it is cute and you're still young enough to be cute because it's cute. Okay? I get it. But I don't want you to go to the high school and say the alligator eats a bigger number, because that would be like asking your friend, like, hey man, you want to eat my Snickers? And you looking at your friend and going, you know what I'm saying? You know how you just get older and you grow up? You know what I mean? I want you to know this is the real name for these things. Think of it like an alligator so you know which way it opens, so you know which way it goes, but then read the sentence. Be able to do both and say to yourself, 2 is less than 3 because this is like an L. L, I love Mrs. McGinnis. That's how you remember L. You know what I'm saying? L with your left hand. L, you love me. L, love and happiness and everything great. Okay, here we go. Now that we have talked about inequality signs and we know the proper terms for them, what sign do you want here? Think about it. Sophia, what do you want? Huh? So you're saying to me 3/4 is less than 5/4. Raise your hand if you agree with Sophia. Yeah, not very many. Not very many. So let's draw it out. Let's draw it out. Hold on, wait. So this, let's do it like this. So this is 3/4 and this is 5/4. I saw on a lot of papers a really good, you guys were writing out how to explain your reasoning, and I'm super proud of you for that. A lot of those words said something like, the smaller the number, the bigger the piece, right? Raise your hand if you wrote something like that on your paper somewhere. Good. That's a good thought. You're thinking, you're remembering, you know that, okay, with fractions, the smaller the number, the bigger the piece. That's good. Now, you have to know where that goes. Because here, what do we know about these numbers? What are those numbers called? Ella?
They're the same.
They are the same. What are they called, Levi? And what is a denominator? Levi?
Bottom.
The bottom number of a fraction. What else is it? Huh? The mirror words.
Yours.
The denominator is
The denominator is
the total amount
the total amount
of equal parts
of equal parts
in a fraction.
in a fraction.
The numerator is
The numerator is
the number that you have.
the number that you have.
Mirrors off.
Mirrors off.
So the denominator is the total amount of equal parts in your fraction. So here we have a fraction here that has 4 equal, it's cut into 4 parts. And this one here is cut into 4 parts. So if I have 3/4, I'm going to have 1, 2, 3. Raise your hand if you agree with my diagram, if you agree with my drawing. So some people do not agree, or we do agree, or we just are tired, or what's happening?
Tired.
Okay, I know you're tired, but I still want you to agree or disagree. So, you're saying that this is an accurate drawing of 3/4, correct?
Yes.
Okay, so how many do you want me to shade in here? How many, Garrett? I've got 3 shaded up here, 3/4. Now I've got this here in 4ths, and I have 5/4.
So you have to shade in 5.
Is he right? He sounds like he's asking me a question. Is he right?
Yes.
Shade in 5?
Yes.
Yes. Good job, Garrett. 1, 2, 3, 4, 5. Now, when we are talking about this symbol right here, what does that stand for? What does that stand for?
Less than.
Less than.
Less than. Less than or greater than. I want you to think about greater than for a minute. Can we list some words? That also mean greater than, that are different than the word greater than? What else would you say? Emmy? More. Okay, sure. More. Ella? Bigger. Garrett?
Greater.
Pretty close, but it's fine. Bentley?
Larger.
Larger. Raylan?
Huger.
Okay, sure. We're trying to find synonyms, aren't we? Gage?
It's a bigger number.
Bigger. We got bigger. Aubrey?
Higher.
Higher. Garrett?
Taller.
Taller. I'm looking for something in particular. This is 3/8. This is 8/8.
Bigger.
Bigger. We got bigger. Gage?
With more shaded parts.
More shaded parts. Ella?
More than.
More shaded parts. We got more. Look here. This starts here and it goes to here. This starts here and it's this much what?
Longer.
Huh?
Longer.
Longer is what I'm looking for. I want you to start thinking of fractions as if they are on a number line. These other words that you guys said, are these wrong? No. But this longer word, I want you to start thinking about fractions on a number line. So I want you to think about them being longer. This one's longer than this one. Okay? So I want you to think about that word longer. So when we look at this, is 5/4 longer than 3/4?
Yes.
Yes, which means is 3/4 is less than 5/4. Is that correct?
Yeah.
Yes. Now, knowing what you know now, look at B again and raise your hand if you want to change your answer or keep it the same. So if you want to keep your answer the same, I want a thumbs up. If you want to change your answer, I want you to just put up 5 fingers. Thumbs up or change. So good. I love your honesty. Be honest. Be honest. I like for you to be honest. Are you allowed to make mistakes in here?
Mm-hmm.
Yes. Does mistakes in math make me upset?
No.
No. Mistakes in math are good because that means you are learning how to do math. And if you already knew all the math, I would be out of a
Job.
Job. If you already knew all the math, I would not have a job. Am I right? Y'all are tired, man. My jokes are not funny to you today at all. They're usually not funny, but they're usually a little more funny than this. Jeez. Okay. Well, we'll just keep plugging along through this horribly boring lesson. So B, 3/5 or 5/5? Which one's going to be bigger? Ella?
3/5.
3/5 is going to be bigger. Let's draw it out. What do you want to shade, Ella?
3 out of the 5.
3 out of the 5 up here. 1, 2, 3. So this is going to be your 3/5. Is that right?
Yes.
Okay. And then for your 5/5, what do you want to shade?
All 5.
All 5. Okay. And so what does that mean now that we have a diagram that we've looked at? What does that mean? Which one's bigger, 3/5 or 5/5? Oh. This is 3/5 because we have 1, 2, 3, 4, 5 total equal parts. 3 of them is the number we have. This down here is 5/5. We have 1, 2, 3, 4, 5 total parts, and we have 5 colored in. So which one's going to be bigger, 3/5 or 5/5? 5/5 is going to be bigger. So 3/5 is less than 5/5. The reason that we know that to be true is because these numbers tell us that the pieces are the same size. The denominator is the total amount of equal parts. That's the total. Your numerator is the number you have, whatever that is, whether it's shaded or unshaded or however they want the lesson to be. Okay? All right. Let's jump into today's lesson because today's lesson is going to build on that review slide. And our review slide is actually part of the lesson, so that's kind of fun. Okay, today let's compare fractions with the same numerator or the same denominator, shall we? Yes, we shall. You all need to wake up. Okay, now this is a trick, sort of. Find the value of each expression mentally. What's the value of this expression? What's the value of this expression right here that I just wrote? Gage?
4.
4. That's the value of the expression, right? That's what we're doing here today. So when I say find the value of an expression, and I write something like that, you're going to say what?
8.
8. Very good. When you have it, I want you to put your thumbs up right here on your buttons. If you were wearing a button-down shirt, you'd have buttons right here on your buttons. When you have your answer, put your thumbs up on your buttons. Got an answer here? Thumbs on your buttons? Mentally, boys and girls, put your pencils down. Close those cactus notebooks. We're not writing this down. We're just looking at it and thinking. Look at it and just think, what's your answer going to be? Look at it. You can't look at it if I see the back of your head. I know you don't see these numbers. What's my answer, Bradley?
236.
236. I had 136 plus 1 in the hundreds place, right? 236. I don't need to write that down. I can just look at that and know. Now what's this one? 136 plus 100. We got
436.
436. I already knew the answer to this one was 236. This just had two more hundreds, right? Okay. Now this next one. Using the information you know to build, using what you know to build on what I'm asking you for. So you know that that one is 436. How do you use that answer to help you with the next one? I love seeing the counting, lots of counting. Ashley Brock?
536. 506.
What is it, 506 or 536?
I messed up.
She says 506. Who agrees with 506? Good. So you knew this was the same, right? Then you had something different here in the tens place that you fixed. Excellent. You ready for another harder one?
Yeah. Oh.
Use what you have to build on what I'm asking you for. Aiden?
500. 514.
Who agrees with Aiden? 514. Good job. Very good job. How did the first couple of expressions help you reason about the last two expressions? Aiden?
I counted 8 and 6 together and it equaled 4. So I carried the 1 over to 7 and that made 11.
Keep going. You're doing good.
And then I carried the 1 over. I carried the 1 over 9 and then I added 146 to it.
Very good. 514 is your answer. I have a paper to pass out to you. Oh, here they are. Right here underneath my Chromebook. Okay. I am passing out a diagram that looks just like this. Hey, Will, you're just going to have to draw this at the bottom of your Cactus notebook in the classwork section, okay? Just do the best you can. Okay. As it says, the diagram shows a set of fraction strips. Label each rectangle with the fraction it represents. I want you to talk to your table. Do this as a table. Do this with your group. Good job. I should hear talking. You're working at the top on number 1. Filling in this diagram. You see what you're doing here, Will? Yeah, what fraction goes in those first two sections? Turn your mic on. You're okay.
1/2 and 1/2, and then
Keep going.
1/3, 1/3, 1/3.
You got it, brother.
1/4, 1/4.
Yep. Make sure as you're filling this out that you are labeling each rectangle with the fraction it represents. Are you going to be putting just plain old numbers in these boxes? No, you should be putting fractions in there. I'm going to give you like 2 minutes to do this. This should be pretty quick. This should be really quick. Get to work. Be quick.
Okay, so now first,
Okay, put a 1 up whenever you're done with this.
That's the whole. Good. And so this is a half. 1. This is 1 half. And that one is 1 half. How many total equal parts do you have?
Okay, I'm done.
2. So that's going to be your denominator for both.
Everybody next.
And then the one side you have 1. The other side you have 1.
1/5.
So 1 half and 1 half. Excellent. Is that what that is?
Now you're 1/5.
There's one line here in this box that's a trick. I don't see anyone that has the right answer in this yet. Everyone has been tricked. Every single person has been tricked. It's not my job to trick you. It's my job to train you to see the tricks. Check all of them. You found it? Colton Beecroft's the first one to find it.
I would say the bottom. I already knew the bottom one is 1.
That's nice.
I think it's like Wisconsin. This is there's a trick.
Good job.
No. Wait, it's the trick. I got it. I found it. It's all. Like 2, 5, 6, 7, 8.
Did you find it? Okay, these are whole numbers. This is a whole number. This is 1. So if this is 1, if this is 1, does that mean that this is now 2?
I found it. I found it, guys. I found it. What is it? But they're these are the same.
All right, if you don't have something filled out, we are going to fill it out together, okay? So, in this first box, you should have 1 half and 1 half. If you have the number 2 in there, that's not it because I need it to be a fraction. If you had a 2, then we would have 1, 1, 2 wholes. This is a whole number. Do you understand what I'm saying? So that's why it can't be a number, a whole number. It has to be a fraction. So we have 1 half and 1 half. What are we going to put in this next box? Lila.
1/3.
And here? 1/3 here. And right here? 1/3 here, right? Good. What goes here? Raylan.
1/4.
And here?
1/4.
And? And? And if I have 4/4, how many? If I have all 4 of these, what fraction do I have? Huh?
4/4.
4/4. I said the answer out loud on accident. If I have all those, then I have 4/4. What goes here? Aubrey?
1/5.
1/5. Because the denominator tells me that there are 1, 2, 3, 4, 5 total equal parts in my fraction, right? Ella Davidson, what's next?
1/6.
You sure about that? You sure about that? How do you know? 1, 2, 3, 4, 5, 6. Good job. You're right. And the last one. What's the last one?
1/8.
Huh? 1/8. But Sophia, I want it to be 1/7. See? 1, 2, 3, 4, 5, 6, 7 is what I want it to be. I want it to be 1/7, please. Okay? Thanks. Huh?
You're doing it wrong. It's 1/8.
Why? She didn't. You ain't nothing. You ain't said nothing to me.
It's a box.
But 2, 3, 4, 5, 6, 7. That's the pattern.
Count all the boxes.
You can't do 7 or 8 because there's 8 boxes. It's not 7.
Count the
Count the
boxes.
You have to count
What?
the boxes before you do it.
1, 2.
3, 4, 5, 6, 7, 8.
Oh, so they were trying to trick me, right?
Yeah, we had that problem too.
Oh.
I did it. Because I didn't even write it down.
Who was the first one to see the trick? Colton B. Craft, my man. Don't be tricked. 2, 3, 4, 5, 6, 7. It's so easy, Miss McGinnis. That's the easy. Well, the easy way is a lot of times is the wrong way. So don't take the easy way because a lot of times the easy way is the wrong way. Okay? You guys tracking with me? You see what we're doing here?
Yeah.
Okay. You should have your fraction strips filled out. Everyone here should have their fraction strips filled out. Okay. Now, circle the greater fraction in each of the following pairs. 3/4 or 5/4. Which one am I going to circle, boys and girls? Notice we did this in our reveal slide. Bradley.
5/4.
Hands if you agree with Bradley. Great job, Bradley.
Great job, Bradley.
Letter B, 3/5 or 5/5. Raylyn.
5
Who agrees with Raylyn? Great job, Raylyn.
Great job, Riley.
Now a new one. 3/6 or 5/6. Be ready to explain your reasoning. Aiden. 3/6 is bigger?
Oh,
Because it wants the greater fraction. 6 is your total amount of equal parts. So do you want 3/6 or 5/6? Raise your hand if you agree with Aiden. You want 5/6. Great job, Aiden.
Great job, Aiden.
3/8 or 5/8? Garrett.
5/8.
Who agrees with Garrett? Great job, Garrett.
Great job, Garrett.
3/10 or 5/10? Will, are you wanting to play in this game? What do you want, Will? 3/10 or 5/10?
5/10.
Raise your hand if you agree with Will. Great job, Will.
Great job, Will.
Very nice. So, what pattern do you notice about the circled fractions? What do you notice here, Olivia?
They all have 5 on the top.
Can we change the on the top to something else? Can you say something besides on the top? Say that again. Just don't say on the top.
They all have 5 in the numerator.
They all have 5 as the numerator. Say, great fix, Olivia.
Great fix, Olivia.
Good job. Who else notices something? Will? You're not Will. You're Levi.
Because the denominators are 4, 5, 6, 8.
4, 5, 6, 8, 10. Talk more about what you're wanting to say with these denominators because it's very important what you're trying to see.
The number on the numerator or the denominator keeps going up. The number keeps going up every time you go down.
Okay. Who else wants to? Michael, will you say more about that?
On all of them, on the, like, 3/4 and 5/4, they both have the same denominator,
So this one here has the same denominator you're saying, correct?
and all of them do.
Well, they all don't have 4. But these, they all match.
Yeah.
The denominators are matching, correct?
Yep. Yes.
The denominators are matching. When the denominators match, if the denominators are the same, that means that the pieces that are being used, well, see if I could the pieces that are being used are the same size. Are you tracking with me? So if the pieces that are being used are the same size, then doesn't that make it easy to tell which one is bigger? Doesn't that make it kind of easy to tell? Do you understand what I mean?
Mm-hmm.
So if I have, so those of you online, kind of try to zoom in on my actual board here, the actual picture of me talking. If I have fourths here, then if your eyes are on me, if you're drawing or doodling or playing, you're not listening. If you're not listening, you're not learning. And if you're not learning, I can't help you. All I can do is stand up here and talk and try to get you engaged. But if you're not going to engage with me, then I can't, there's nothing more I can do other than try to make this more interesting. I'm doing the best I can. You understand what I'm saying?
Yeah.
It's going to get interesting, but until we get the basics of what we're doing here, we can't have fun and play games until we have the basics of what we're doing here. So look at your diagram. You have these on there. If I have a fourth of a Reese cup, or I could have 3/4 of a Reese cup, what's your teacher going to choose? Ashley? 3/4, because that's more, right? That's more fourths. So when your denominator is the same, then you are free to just look at these numerators and decide which one is bigger, right? So with that being said, let's look at which one is greater here, 7/3 or 10/3. Be ready to explain your reasoning. Talk to your table. Which one's bigger, 7/3 or 10/3, and why?
10/3.
Talk to your table.
Because the denominator is the same, and the numerator, I don't think it is not the same.
But 10 on theirs is
But the 7 and 3 will make a bigger piece.
Bradley, I want you to lead this discussion.
Since the bottom of 3, we're free to look at the top.
Since both say, can we use a different word besides bottom?
The denominators are the same, so we're free to look at the top. And 7 smaller than 10.
Since the denominators are the same, here he's saying that these denominators are the same. That means that our pieces are cut into the same size. Our denominator is the total amount of equal parts. So since we have a set of thirds and a set of thirds, we're free to look at the numerator, right? The numerator. We have the denominator and the numerator, right? So what did you say your answer was, Bradley? 10/3. Raise your hand if your table talked about 10/3 being larger. I know these guys were. I know these guys were. You guys back there were too? And these guys here? You guys were kind of mixed, were you? Okay. What do you notice about each pair of fractions in the second? What does it mean when two fractions, say 3/8 and 5/8, have the same denominator? What does that mean when they have the same denominator? Ella?
Have to add the numerator.
We're not adding anything. I just want you to think about these two fractions, 3/8 and 5/8. What does it mean, Garrett, when they have the same denominator?
You're free to look at the top.
At the what?
At the numerator,
Yes. Because why?
because if they're both the same at the bottom, it's the same fraction.
It's the same size piece. When your denominators are the same, you have the same size piece. And so I have 3/8 or 5/8, correct? When your denominator is the same, your numerator, you're free to look at the numerator because you know your pieces are the same, right? Okay. Now, let's do this. I'm gonna see here. I want table 1, I want you to do A. Table 2, I want you to do B. Table 3, I want you to do C. Table 4, I want you to do D. Table 5, I want you to do E. And table 6, I want you to do A. So A, B, C, D, E, A. All right? Circle the greater fraction in each of the following pairs. So find your pair. Use your cactus notebook, or you actually take that paper I passed out and turn it over on the back. It's blank. You can use the back for like scrap paper. A, B, C, D, E, A. Go to work. 2 minutes again.
So guys, which one is this?
You have a disagreement. You got to prove it. What's the game where you battle?
So put A or B.
Hey, Will, talk to me about A. What do you got for A?
A would be 1/3 because
Be kind.
if you split a Reese cup into 5 parts, and if you split one into 3 parts, the third would be bigger.
Good job, Will. Love your explanation of Reese cups. Where'd you ever come up with a thing like that?
You?
Ha ha, my man. All right. So Will and I talked about letter A. I want to talk to table 1 about letter A. And then you guys are going to tell me if you agree. Okay? Go. Table 1. Quickly, please.
1/3.
Huh?
We picked 1/3 because smaller the denominator, the bigger it is.
Agree?
He said 1/5.
Whoa. They say 1/3. Why did you say 1/5?
We said 1/5 because the numerator is same because 1 and 1 are the same because they're equal. And every time when we had those other questions, it was always the smaller the denominator was. Because on the other one, it was with I think it was 3/4. On the first one that we did, you said 3/4 was less than 4/5.
Then 5/4. Right. Because on the other ones, were the numerators matching or were the denominators matching?
Denominators.
The denominators were matching. Do the denominators match here?
No.
No. So that means that what is not Will, you need to step in and be the tiebreaker here. Turn that microphone on and I want you to explain. I want you to say exactly what you said to me, loud and proud, so everybody can hear you.
It is 1/3 because if you split a Reese cup into 5 parts and 5 parts and 3 parts, 1/3 would be bigger than 1/5.
Will's saying that if you take a Reese cup and you cut it into 3 parts, 1, 2, 3, this Reese cup's into 1, 2, 3, this Reese cup's into 1, 2, 3, 4, 5, which one do I want? The 1/3 or the 1/5?
1/3.
Why?
Because
The 5's bigger though. That's what they're saying.
yeah, but
They're saying the 5's bigger.
say you have like friends over, and they each want a Reese cup, but they think it's too small, so they grab 2, and your other friend grabs 2. You only have 1 piece. But with the 3, one friend can have 1 big piece. Your other friend can have 1 big piece, and you can also have the same amount that they have, so it's fair.
So you're saying that if I cut, so you guys back here, if I cut a Reese cup into 3 pieces, because the denominator is the total amount of equal parts. Don't move. So if I cut this into 3s and this into 5s, do I want the 3rd or the 5th? I want the 3rd. What about B? Who had B? Table 2? What'd you say? 2/3 or 2/5? 2/3. Well, we had to have a little battle back here, didn't we? Yeah? Tell me why you joined the other team, Levi.
Because 2/3 is a bigger piece than 2 fifths.
Because 2/3 is a bigger piece than 2/5. Table 3. Y'all, stop. I'm not done. Table 3. What'd you got for table 3? What'd you got? Or for C? Go, Aiden.
We picked 3/3 because it's a whole piece, and 3/5 it's not a whole, but the denominator might be bigger, but the pieces are smaller.
Very good, Aiden. Aiden is saying, he's like, we picked 3/3 because we know that 3/3. Ladies and gentlemen, I'm going to ask you to sit still. Because what Aiden is saying is very important. And if you're trying to pack up, you're not listening and you're missing out on something important. Stop. Aiden is saying we picked 3/3 because we know that if we cut a Reese cup into 3 pieces and we get all 3 of those pieces, then we've got the whole thing. But if we cut a Reese cup into 5 pieces and we only get 3 of them, do we have the whole thing?
No.
No. Table 4, what'd you get? 4/3 or 4/5? 4/3. You get more than a whole thing, don't you? Get it. And table 5, what about here? 9/3 or 9/5?
9/5.
We're changing our mind now that we've gone through all of them. We're changing our mind. That's good. 9/3. What pattern do you notice here? Ella? All the denominators that are bigger are 3. This is when the smaller the number, the bigger the piece. When it's your denominator. When it's your denominator. Okay? All right. We'll talk more about this tomorrow in our lesson. Will, you did a great job. This concludes our lesson on same numerators.